a pleasure being a part of the Tech Talk. Thanks for the opportunity to talk to you about WAGO and what we're doing in the application controller redundancy. I wanted to start by just saying a few words about WAGO. We've been partners with WAGO for over 20 years now. We released our first CODESYS-based controller in the early 2000s, and just have built upon that throughout our line of controllers that we offer. So we have the PFC series, we have a whole series of industrial PCs and touchscreens, and all based on CODESYS. And we were one of the pioneers of putting Dockerized containers on Linux-based controllers. So we have a lot of experience with that. In North America, we have, including Canada, we have over 20 apps engineers throughout the continent, and we have over 200 years experience if you add up all of the seniority with the engineers that we have on staff. So we're really prepared to support CODESYS and help integrate it in many different industries and applications. So what we're going to be talking about today, though, is specific to an application called the WAGO ACR. It's an application controller redundancy. And we'll talk a little bit about why we would use redundancy, the different types of redundancy and applications where that might be used. And then I'll pass it over to Jeff, and he'll go in a little more detail about the application and do a demo. So the area that we're going to be focusing on here is the area in green. This is where we would have a CODESYS-based runtime, and then remote I/O, which would be connected over a network. So the application-based controller redundancy is a WAGO solution that provides a high redundant, high availability system. It's based on a set of WAGO libraries that integrate right into your CODESYS program. And then really the key to it is what we call a smart coupler. And Jeff will get into a little more detail about that, what that is. But essentially, it's a small PLC that runs a pre-built application that makes it work like remote I/O, but it's kind of the key to the puzzle to make this all work. And then we have a lot of certifications that allow this application to be used in extreme environments with our XTR series, as well as marine certification. So depending on your specific needs, we probably have the ratings and certifications for those. So if you don't have a need for redundancy, or you've never used redundancy, these are some reasons why you would perhaps want to look at that. We see a lot of interest in life safety systems. So think of a factory that needs to monitor gas detection, or where there might be fire alarms or emergency lighting, things like that. Areas where if there's a problem with the controller failing, it might damage equipment, which would lead to costly repairs, or damage to product or spoiling of product if let's say air handlers turn off or something, and you start to temperature starts to get too warm. As well as anytime there's a uptime concern where you need high availability, that having a redundant controller potentially could mitigate some of those issues and allow for a higher uptime. And then if you're doing any kind of data acquisition where there's regulatory requirements that you have to maintain data collection over a certain period of time, having a redundant controller there to help with that collection of the data is also beneficial. So several different types of redundancy. The simplest is what most people are probably used to, which is essentially having a failover PLC that's on has the application loaded. The settings are all ready to go, and you can just switch over. If you have a PLC fail, you just switch over to the backup unit, and it's off and running. So that's more of a manual intervention would be required to switch over to the standby. Where a warm standover is beneficial is that it's more automatic. So you have two controllers that are talking together, and there's a problem with the primary, then it will switch over to the redundant, automatically, and you don't have to have someone physically do that. So that's where the ACR, the WAGO ACR fits. It's basically a automatic system that you just institute in your system, and that will monitor the network and switch over. And then you have a hot failover, which is more on a high-end systems where you're going to pay a premium for this. It's used in very high performance, high cost platforms, and typically you require dedicated hardware, specially made boards that are wired together, and they provide this failover in under a millisecond. And there's definitely a need for this kind of redundancy, but I think you'll find that the warm standover is a kind of a good price to performance ratio. Just wanted to touch on some of the industry examples of where you might have a need for redundancy. We're seeing a lot of interest in data centers. We talked about how downtime can be costly, and that is very true in data centers, where you have racks and racks of servers that need to have high availability. They're running critical applications for customers, and part of that is managing the facilities, both the cooling systems as well as like power. So I've got a ton of acronyms here. AHU is air handling unit. The CRAH is computer room air controllers or air handlers. So you want to make sure that you're controlling all those fans and the airflow that needs to happen to pull all that heat out of the servers is very reliable, because if there's ever a break there, then you're going to start overheating servers, and obviously that's not going to lead to good things. In addition, there you need to support a lot of the BMS systems and protocols that are used in that space. So because we're using CODESYS and we have a lot of additional libraries that we can add into CODESYS, we can do things like BACnet, and we can integrate with a lot of other protocols like Redfish for CDUs and things. And then on the power monitoring side, we do a lot with the energy. We have a whole telecontrol library that we offer, and that will allow it to talk to a lot of SCADA EMS type systems, and it's really perfect for controlling UPS and gensets and switch gears. And then in addition to data centers, we play in a lot of different markets. So we have a lot of interest in the energy space, where obviously, power, when you have interruption in power, there's a lot of impacts downstream of that. So things like substation control, oil and gas, microgrids, all the alternative energy space with batteries and things. So we are doing a lot with our ACR in this space. And then for marine, you'll find a lot of need for redundant control in marine, because if you are losing propulsion or control of positioning, that can really cause a lot of problems. So we have the ratings for this application as well. And then lastly, semiconductor is another good example, where you have very expensive machinery in a semiconductor plant, and you need to supply those systems with water, with waste handling, air handling. So it's similar to the data center space, where you have to have a lot of control and redundancy around the facility side of things. So another good application use of the redundancy. So with that, I'm going to pass it over to Jeff. Thank you.
Thanks, Kurt. So from the video here. All right, there we go. Okay, so I'm going to talk a little bit more about the nuts and bolts of the ACR, application-based controller redundancy system. This system consists of pre-built function box and POUs that are basically just, you can download it from our website and you install on your controller and spin it up and you're ready to go. It's all written in CODESYS. So these are all CODESYS written function blocks within the CODESYS environment. As Kurt mentioned earlier, it's a warm switchover. So it's 100 to 200 millisecond switchover time. And that's really related to how big your user program is, how fast you're cycling, running through your programs, and how many resources you're using in order to do whatever it is you need to do. The way this works is that it uses a UDP data transfer between the two masters of 1468 bytes. And that 1468 bytes comes from the frame size for a standard Ethernet frame. And so that's the maximum frame size for a single Ethernet transferring a single Ethernet frame from one device to another. And that's an industry standard. I know that's not a WAGO thing. That's your laptops, your any of the devices that other presenters have shown. A single UDP packet is going to be that size. And the reason we limited that is to make sure that you're not having any synchronicity issues. When you've got multiple packets going back and forth, and putting your data in multiple packets, you can potentially have syncing issues if you've got timers or counters or something like that. So we try to keep it within one packet. We are looking at trying to see if we can use the jumbo frames, and jumbo frames are around 9,000 bytes, which would be nice to have a lot more data going back and forth. But you also need a gigabit switch capability or gigabit capability on your Ethernet ports on your devices. So we're looking at those PFC300s. There's individual application for each of the masters, and then a common user program that is common between the two. So if anybody's looked at the CODESYS redundancy, it's similar. The user side is very similar in that you have a single user program that transfers, that gets loaded into both sides. And each master has its own individual application that's running. One thing that's kind of nice about that is you don't necessarily have to have the exact same device on master 1 and master 2. So for instance, in WAGO's case, you can have a 750-8212 on one master, and you can have an 8216 on another master. It doesn't really care that those two devices aren't exactly the same. They just have to be the same type. So when you're setting this stuff up, it really requires only your IP settings, add the licenses, and off you go. So everything is pre-canned in this system. There we go. Yep. So we have two different network architectures available when you're using application-based redundancy. One is the dual LAN redundancy, and the way this is set up, if you can see the diagram, is there are two completely separate Ethernet networks set up for the redundancy system. This makes it a little easier to set up. You can use unmanaged or managed switches, but if you want to use unmanaged, it lowers the cost and complexity. However, it requires two Ethernet ports on the PFCs, which now that you've used those two ports, it adds some complexity for interfacing with external systems, and that both ports are used up. On the dual LAN system, you can have up to 20 smart couplers. And as Kurt mentioned earlier, the one thing that's unique about this particular setup is with the smart coupler is actually aware of the masters. It's not a dumb remote I/O device. It knows which master is primary, and it is actually doing data transactions between whichever masters it needs to. So the advantage of having that intelligence on the remote I/O device is that it is aware of what's masters, and it can interface between those two and can know when either or both masters are missing. And I'll go into it a little bit, but there are some configuration settings that you could do in this smart coupler to allow it to behave in a certain way if it loses communications with both masters. So it, in essence, acts as a kind of a triple redundancy in that regard, which is a nice feature. The other option for redundancy is single LAN. So single LAN, we just do a ring architecture, and We can do EPRS. We can use jet ring. We can use RSTP. The jet ring is WAGO's proprietary version RSTP, which is a little faster. In the case where the demo I'll show in a minute, I actually used ERPS. I did that just because I think that's going to be a little more common. And for those who aren't network engineers, ERPS is Ethernet ring protection switching. It's a global standard. The ERPS is widely used throughout the industry. If some of you guys on our network guys, you've probably heard of it or used it before. For the single LAN, because of capabilities and within the system, we can do 18 smart couplers rather than 20. And it does use managed switches. And one thing that's nice about the single LAN is it only uses one Ethernet port on the masters, and that allows the other Ethernet ports available for SCADA integration. So it's a little easier for SCADA integration on that port. All right, so I will switch over to bring up my VM here, so if I can find it. All right, let's see, show my script so I can find the VM. There we go. So I'm going to show you here, like I said, I've got a live demo going on behind me. And this is, what I'm showing you here is a built-in visualizations that are pre-canned that come with the ACR application. So right now you can see that master one, you can see the lamp in the middle here is actually on standby. Master two, your primary master. So he's the one that's driving the bus right now. You can see on the bottom, I've only got one smart coupler connected for the demo, but along the bottom here, what you'll see is for every smart coupler that's attached, you'll see it populate along the bottom here. And what's really nice about this is when you're monitoring the system, if you see a coupler missing, you know that for whatever reason, maybe it's got power down, maybe it's lost comms, for whatever reason, you'll know that, okay, something's wrong with this one. It's not showing up on my, it's not showing up on the visualization here. So you can go and check out and see maybe what's going on with that coupler. So any coupler that's actively attached will be shown beneath here. So this is master one. If I go to master two, it looks the same. Obviously these slides, so master two is the primary, master one's a standby. Like over here, right here, what I'm doing is I'm logging into the smart coupler itself. So this is a smart coupler. So there's a lot of good information on here. What you're seeing is, in this particular case for the demo, I've got two I/O cards on here. I've got a 430 and 530, so the digital discrete input and a discrete output. And what you can see is, you see, there we go. What it can show you is it automatically populates the I/O for you. You don't have to create a I/O config on this one. The upload software that's installed will actually go through and find your I/O cards and populate them for you. So you can see what's going on here. If you click on the master up here, you can see that it sees both masters. So this is kind of what I'm talking about the smart coupler being able to see the masters and knows the status of the masters. So you've got two greens that's telling the smart coupler that, okay, both my masters are good, and it shows the IP addresses. Go back to this. So what I was talking about earlier, there we go. That's what I want to show. You can see the live values that are on the discrete output card. So those are the actual values being written. And when I switch over the camera view, you will see the LEDs on the discrete output card actually change. And on this screen, you can actually see how we can change behavior. So the smart coupler. So you can have, if you lose communications with both masters, you can have no output, in which case all the outputs turn off. The second option is hold last state, in which case all of the outputs remain in the state that they were when communications were lost. They just stay there. And the last is set substitute values. And what you're doing there with set substitute values is you can actually tell the coupler if upon loss of communications with both masters, what state that each of the outputs go to. So if you have a process where you have a known safe state or kind of a limp home mode or something like that, where you've got a process is running, you lose communications to the masters, okay, what state does that thing need to go into continue to maintain a safe operation or an orderly shutdown or something like this? You can add in and say, okay, I'm going to set the values, and you can do that here. I'm going to set these outputs to particular values that I choose upon loss of communications. Now I will switch to the camera. And here it is actually running. So you can see on the output card here, this is just the demo program that is running right now. All it's doing is circulating around the output. So output 1, 2, 3, 4, 5, just going in a circle to show that it's running. Up along the top, you see master 2. You've got an LED here that's on solid. That's telling me that it's the primary. And then this one over here, you can see that one blinking. That's indicating that that's a secondary. And then I've got some power switches I added over here on either side, so I can power these off and actually show what happens when you remove power. So right now it's actually running a program. It's operating. What I'm going to do first is I'm going to pull out the Ethernet cable out here to assume that lots of comms. And so right now you can see this one is master. When I take it out, if you'll notice, the lights are still moving, and as they were before. So I disconnected the Ethernet from what was master, and it's still working. It switched over to the secondary immediately. You also see, it's hard to see on the screen, I know, but if you see here, the top LED is yellow and the one beneath it is red. So this one, he's lost sight of both the smart coupler and the other master. So he thinks he's in standalone because he doesn't see anybody else, but he also doesn't have visibility into the smart coupler. So he knows that something's up. So still on the top one is yellow. He's lost sight of the other master, so he's operating in standalone. So okay, the other master is gone, so I'm just going to operate as a single PLC now. Put him back in. So you can see it just took a couple seconds to recover. And I'm going to go to turn off. So this one is, this one's the primary master now. This is secondary. When I turn him off, the lights are still functioning as they were before. There's no interruption. Again, a yellow light at the top indicating that he's in standalone, that he is not seeing the other master, but the process continues without any interruption. I turn that back on, and then he'll boot up. And then when this one boots, it'll take a minute, so I won't leave the camera on there because it'll take a little bit for him to boot up. But once he does, this one will be the primary master, and then this one will be the backup at that point. So, going into a little bit of the differences between WAGO's HCR redundancy and this the pure CODESYS redundancy. On the WAGO side, there's an ease of implementation. Everything is pre-written and everything's pre-built, and you just have to install it into your PLCs and set your IP addresses and connect everything up, and you're off and running. Configurable smart coupler behavior. When I showed you the various settings that you could do, offers kind of a pseudo third level of redundancy, is a big advantage. Built-in network redundancy. Network redundancy is included in the WAGO application, either dual LAN or single LAN. The master programs and the smart coupler programs have that already built in. So use a standard Ethernet, Modbus, network variable lists, UDP. Requires fewer NICs. If you're using the single LAN, you only require one Ethernet port. You do require two on the dual LAN. And then on the CODESYS side, so what's really nice about the CODESYS redundancy is support for EtherCAT, Profinet, CAN open. It's more lightweight, and because you don't have the pre-built, if you want to go super basic and just the bare minimum and make it really lightweight, you can. Also, there's a little bit more flexibility in that the CODESYS redundancy allows you to build your own custom redundancy to work exactly how you want it and code it your way. And then fast failover because of the EtherCAT capability. You can take advantage of the EtherCAT speeds to increase your failover speed. And yeah, and that's ACR. If you want, take a screenshot of this, and so you can get a hold of Kurt or me. The website, I've got the website on there, is directly to the ACR website. From there, you can bounce to any of the other WAGO. Also, sales and distributors, and also tech support phone number on there if you guys want to talk to anybody a little more detail about tech support. So that's WAGO ACR. I appreciate it.